Hello everyone, welcome to another class of fundamentals of food process engineering. We are in the first chapter, that is food rheology, and we will continue today with the problem that we should do on measurement of rheology. So, regarding measurement, what are the different methods and what are the principle behind that? We have learned it in our last class. Today we will continue. So, next we will cover the rheological behavior of semi solid food. So, semi solid food, which is also called the viscoelastic food. So, we will see first the viscoelastic behavior, and then we will see that what are the different kinds of model that can well explain the viscoelastic behavior and the main characteristics features of viscoelastic behavior. So, first we will see that why it is different from the solid and viscous behavior we have learned so far. So, as the name suggests that viscoelastic material, they must have viscous property, that is the flow property, and the elastic property, which is the characteristics of solid material. That means, they show both the elastic as well as viscous property at the same time. So, they possess some degree of elasticity and also they flow some degree. So, the full recovery of the initial condition may not be possible in this case. Let us see that what happens when a constant stress applies on a viscoelastic material. Here we have a plot where a constant stress tau has been given here according to this line, and it is maintained at that condition, at a particular shear stress is being maintained for certain time, and then it has been withdrawn. Okay. So, let us say if T equal to T1, we are giving this constant stress, and then T equal to T2, it has been withdrawn. Now, what happened to the elastic material, that since stress is proportional to strain in pure elastic material, it directly come to the condition of the stress proportional to the stress, and then instantly again come back to the initial condition if it is purely elastic material. However, if it is purely viscous material, so as the stress comes on the material, so a constant stress, so it will start flowing continuously. But for a viscoelastic material, it starts increasing the strain and may not be reaching to the exactly similar degree of the applied stress, and then when we withdraw the stress, it will try to come to its initial condition exponentially, not instantly. And because it has some viscous property as well, that means it has some flow properties, that is why it cannot fully regain the initial condition. Because of this elastic nature, it regain some of its nature, but not fully. So, this is the nature of strain that will be observed as a result of a fixed pulse of stress which is applied on a viscoelastic material. Okay. So, now we will see that if the material is having viscous nature, to having a higher degree of viscous nature compared to the elastic nature, then its relaxation time will be very short, and if it is having more elasticity, more elastic nature compared to the viscous nature, then it will show a longer relaxation time. So, one important characteristics is de-Borah number represented as d suffix e, that is the ratio of characteristic time period of material divided by time period of observation. Now, if the characteristic time period of the material, that means the time to have the full relaxation will be very low, as the high viscous material will be, I mean in the viscoelastic material where component of viscous material will be higher. So, they will have very low de-Borah number, and the reverse will happen in case of the material which is having higher degree of elastic property. Okay. So, de-Borah number can give us some indication of the nature of the viscoelastic material. That is why this is very important parameter, and it also depends on the time of observation. So, if the material is having a really longer period of the relaxation time, so we should take the time of observation accordingly. So, relaxation time constant for a viscoelastic material can be used for the characteristic time period analysis of the material. Now, here are the example of the viscoelastic food like wheat flour dough, dairy cream, ice cream mix, marshmallow cream, cheese, most gelled products. These are viscoelastic food. That means they possess both the viscous, that is flow behavior, and elastic behavior, but the degree of elasticity or degree of the viscous nature may vary depending on the different molecular construction of the material. So, therefore, there is no simple constant for viscoelastic material such as modulus, because the modulus will change with respect to time, because most of the viscoelastic material shows significant deformation behavior with respect to time. So, we will see an interesting phenomena here. Viscoelastic material which is having some special property which is visible compared to the viscous material. So, if we take a rod if we dip one rod into a viscous material, okay, and give a rotational movement to it, then we will observe a vortex in the liquid. Okay. So, it is clearly visible. Now, if we take a similar rod and try to agitate the viscoelastic material, okay. So, take a viscoelastic material, then we will find that the material will try to stick to the inner rod and try to come up with the rod. So, this effect is called Weissenberg effect. So, example is you can see this kind of behavior in cake batter or bread dough. So, the reason is that production of a normal force acting at the right angle with the rotational forces, which in turn acting on the horizontal plane, because the rotation tries to straighten or break the polymer molecules in the direction of the rotation. However, they have a tendency to come to its initial condition, they try to spring back and put a normal force because of that, because they want to come to the initial condition, and therefore, this kind of effect, which is Weissenberg effect, is seen in many viscoelastic material. So, another phenomenon that we can see in case of viscoelastic material, that if let us say some fluid, some viscous fluid, if it comes through a long tube and when it comes out, so that time contraction happen. Okay. So, if the diameter is d, so the material which comes out to be from the long tube, if it is a viscous material, so its diameter will be reduced or the material will be contracted a bit. Now, if we see the in case of low viscous material, then we can see, that means Reynolds number is low, then we can see that 10% to 15% larger material may observe when it comes out from the very long tube. Okay. So, during flow, so this time we can get 10% to 15% higher in the diameter, or that means we can get a minor amount of expansion in the material. However, if we take viscoelastic material and the stress is released through the pipe flow, if it comes out to be from a long straight pipe, then almost twice or more times of the diameter the expansion will be visible. And also, if the material is highly elastic, tubeless siphon behavior will be visible. Okay. So, this kind of phenomena you can get it from the books as well. You can refer the M.A. Anand Rao or Steffi book for getting the viscoelastic nature of the material. Another more important behavior, that is called the recoil phenomena. So, what is recoil phenomena? Let us say we have viscous fluid flowing inside a pipe, as well as we have a viscoelastic fluid. So, when we start the flow, gradually the flow will start building up in the pipe, and eventually fully developed flow having a parabolic nature will be observed. And at that time, if we stop the flow, that means if we stop it, it will remain in the same condition. However, if we start the flow in case of viscoelastic material, so it will come up to the parabolic condition, but when we stop it, it will again spring back to a stage which is a previous condition. That means, it is not coming to fully straight, but not retaining that parabolic behavior that it was during flowing, during the fully developed flow. So, this phenomena is called the recoil, and this is happened because of the elastic nature of the viscoelastic material. So, some flow will be observed because of the viscous nature, and some recovery will be there because of the elastic nature. This phenomena is called the recoil phenomenon. Now, the main characteristics of viscoelastic material are stress relaxation. There are method of stress relaxation test, creep test, which is another important phenomena, and lastly the dynamic test. So, this all three tests we perform to analyze the viscoelastic nature of food, or for that matter any viscoelastic material, and this test can very well give us an indication of the degree of elasticity and degree of viscous behavior of the material. So, we will stop here and we will continue in the next class. Thank you.